Alright, I have the sample exam here, and I want to work through one problem for you to give you sort of an approach to tackle these problems. So we already have a general approach laid out. We need to draw, visualize the problem, and that requires that you read it carefully, understand what's being asked. Identify any key theories, models, formulas that are going to be useful for that problem. Solve the problem analytically, ask does it make sense, and then enter numbers as a final step, okay? It also helps to just take a deep breath, carefully read that problem, don't panic, make sure you understand what's being asked, and then you'll be in a position to do your best and to get the answer done well. So let's read the problem together. I'm trusting you have a copy of this before you. So this says that a force, P, 4 newtons, causes a 30 millimeter diameter shaft to slide along a lubricated bearing with a constant speed of U equals 0.5 meters per second. Determine the viscosity of the lubricant mu. Viscosity. This is a viscous problem. Professor Sanders said there would be a viscosity problem, a surface tension. This is my viscosity problem. Okay. So with these viscosity problems, generally it's a force balance. I need to balance two different forces. So in this problem, let's draw a picture. I've got this shaft, okay, and it's being pulled to the right with some force P, and because it's being pulled to the right, it has some velocity U, okay? And then along the outside of the shaft, there is a layer of liquid all along the outside of it, and it sort of covers all the sides. And if we looked sort of at this view here, what we would see is something like this, where this is the shaft in the middle, this is the solid outside, and then there's this gap here, right, that's filled with a lubricating fluid, okay? Okay, so I've got force to the right, that's going to be resisted by a shear stress to the left. So I'm going to start off, I need a force balance, okay, so some of the forces in the x direction must be 0. So that means that P must be equal to some shear force. I'll call that F mu. Okay. P is given, so I don't need to re-express that anyway. I do need to figure out an expression for this shear force. Well, that's going to be equal to a shear stress multiplied by the area over which that stress is exerted, and that's going to be the perimeter of the cylinder, okay? So we'll write down area. Now I know that mu, tau rather, can be described by Newton's law, so I can write that as mu du dy. Okay, in this case I've got the shaft coming this way, so the fluid really close to the shaft is moving at a speed u. The fluid on the outside of the lubricating layer is not moving at all. So this can be thought of as u minus 0 over the thickness of that layer, and we're going to call that layer thickness h, unless something else is given here for it. It's given as epsilon. Okay, so we'll write that down as epsilon. So now I can say that tau is just equal to mu times capital U over epsilon. So I have an expression now for the shear stress. Now I need an expression for the area over which that stress is acting. So I've got this shaft being pulled along. It's got a length, it's got a circumference, and so the area that's important here is going to be equal to pi d, which is the circumference, times the length of the shaft. That shaft length is not given, so I'm going to call that L. Okay, I'm going to call this D. So now I'm going to call this pi dl, gives me my area. So now I can write out an expression for the force. Force equals mu u over epsilon times pi dl, and that must equal to p. So that means that p is equal to mu u over epsilon pi dl. And since we were asked to solve for the viscosity, that means the viscosity is going to be equal to p times epsilon divided by u times pi times d times L. Okay? So, an equal sign there. So now I've solved for mu analytically, and then last step is to enter in a number. Okay, so now I need to put in numbers. So I'm going to use SI units. P is 4 newtons. Epsilon is equal to 1 millimeter, so I have 0.001 meters. U is given as 0.5 meters per second. I have pi. D is given as 30 millimeters, so that's 3 centimeters, so that's 0.03 meters. Okay, and then lastly, L is equal to, oh, it's written here as 50 millimeters. 0.05 meters. Okay? So if I worked out those calculations, I would end up with a value for the viscosity. So I'd have viscosity equal to a number, and the units I would work out to be are should be kilograms per meter per second. Okay?